This is Mr. Precella with my college algebra class this morning, and we're going to discuss the distance and midpoint formula when working with the rectangular coordinate system. Remember that with the rectangular coordinate system, that's the fancy name for the x-axis and the y-axis all of y'all have worked with before. You have an x-axis and a y-axis. And we have positive numbers going to the right and up, and negative numbers going to the left and down. We plot ordered pairs in the form x, y. For instance, this ordered pair right here would be the point right 2, up 3, so that would be the point 2, comma 3. We're sort of reviewing this rectangular coordinate system before, that all of you have seen before. Ordered pairs are always in the form x, y. So the first formula we're going to see is something called the distance formula, and if you're familiar with the English language, you can probably figure out what it's going to calculate based on the fact the name is the distance formula. With the distance formula, this calculates the distance between two ordered pairs. If we had 2 points, what's that distance between them? Now, I'm going to call these points, each ordered pair, if you just want to refer to it as a variable, with variables, they're x, y, but I can't call both of these x, y because then you won't know which one I'm talking about. So I'm going to have subscripts on these, x1, y1, that's the first ordered pair I've labeled, and x2, comma y2. These are subscripts. X sub 1, y sub 1, x sub 2, y sub 2 is how some people might say it. I have a hard time with that sub 1, so I'll just say x1, y1. Okay, that's my lazy way of doing it. So the distance formula, that's the first formula I'm going to state. It's calculating this straight line distance there. Then there's something called the midpoint formula, and it actually gives you the ordered pair that's just right in the middle. So we have distance, and then the point right in the middle, that's what I'm referring to as midpoint. And oh wow, that's a messy picture. I think I'm just delaying the inevitable. I need to just state the formula. So here they go. Let's suppose we have 2 ordered pairs, and I'm calling those ordered pairs x subscript 1, y subscript 1, meaning just there's the first ordered pair, and here's the second, x subscript 2, comma, y subscript 2. The distance between these 2 points is given by this formula. D for distance equals, and there's going to be a big square root, second x minus first x, so x subscript 2 minus x subscript 1. So we subtract the x's, then you're going to square them. All of this I'll explain in a moment where the heck this comes from. For those of you wondering, why does this calculate the distance? So x2 minus x1 squared plus y2 minus y1. Those aren't exponents. All it means is second x minus first x, second y minus first y. I'll justify why that works or why it calculates the distance in a little bit. But first I'm going to do an example, and I also need to go ahead and state the midpoint formula. Okay? How do we find the point, the ordered pair right between these? Well, if someone asks you, what number is right between 5 and 7, what would you say? 6. What if I said, what number is right between 28 and 37?
29.
28 and 37. 29's between it, but it's not the one right in the middle. What if we go like this? 40 and 60. What number would be right between 50?
50.5.
Okay, I'm thinking it's just 50. Between 40 and 50. How do you find a number that lies right between two numbers? You average them. 40 and 50. 40 and 60. The number right between 40 and 60 is 50.
Do you subtract the smaller number from the bigger number to get the midpoint?
Oh, to get the midpoint, I'm thinking just average. Add them up and divide by 2. What number is right between 40 and 60? If you went 40 plus 60, that would give you 100. Divided by 2 is 50. And I think if you imagine the number line, right between 40 and 60, isn't 50 there? Or if we went with smaller numbers, 4 and 6. Number right between 4 and 6 is 5. 4 plus 6 is 10 divided by 2. Average gets you that number right in the middle. So the midpoint is given by, or let's say is calculated by averaging the two x values and then averaging the two y values. So to get the midpoint, if we want to write it as a formula, how do you take two numbers and average them?
Plus.
You add them together and then do what? Divide by 2. You average by adding the two numbers up and dividing by 2. You average the x's, so that's just x1 plus x2. Ooh, let me move this up. Divide by 2. And y1 plus y2 divide by 2. You could convince yourself that that midpoint formula works just by thinking in terms of numbers. What number's right between 4 and 5? Well, it's 4 1/2. 4 plus 5 divided by 2, 9 over 2 is 4.5. Just averaging the x's will get you the x value that's right in between the 2 points. Averaging the y's will get the y value that's right between the 2 points. Now, I cleared out my box, which is not a good thing. I guess I should say hi to the people in Japan that are watching this. My brother was looking this morning, and next to the U.S., people in Japan are watching these videos. I suspect they're laughing, okay? And so I was like, oh wow, why are people in Japan? I think the countries next to the U.S., it's Japan, Philippines, and India. I figure there's some celebrity with a name similar to our last name, which is so unusual that maybe they're mistyping the celebrity name and they're getting to this thing and what the heck is this? So anyway, I'm going to do this problem. This is number 1 in your homework. Problem 1 and 2 are both just like this. find the distance between the 2 points. I'm going to, oh wait, let me do this. It says find the distance and then find the midpoint. So let me put this so we can see both of them. And we're just going to treat it as a formula, and once we're completely through with this problem, I'll try to justify what this distance formula is doing. Okay? Why does the distance formula work? For those of you that are wondering why. So I'm going to go ahead and rewrite these ordered pairs, or if you just want to label them, x1, y1, x2, y2. I think I need to write them bigger. So here's my first x, first y. Remember, ordered pairs are always in the form x, y. So a common mistake students will write x1, x2. No, these are x, y's. And the subscripts, all they're doing is keeping track of first x, first y, second x, second y. Now, I'm just plugging into the distance formula the way I have it written. Again, I haven't justified why it works or told you anything other than this is it. Let's substitute in x2, that would be 2, minus x1, be careful, that minus a negative 5. Let's see if we can have a plus in there. Now, y2 minus y1, that'll be second y, minus first y. Now, I deliberately regenerated this problem until I got something with messy negative numbers and stuff. Probably on your number 1, there won't be any negative numbers. My number 1, when I printed it out, I gave up after a while, kept printing it out. And notice, it's just nice little positive numbers, 9 minus 4, 17 minus 12. I wanted something with negative numbers or something at least a little messier to do in class. And so I printed it out on the teacher side of things. So now, let's simplify what's inside here. Inside the parentheses, we have 2 minus a negative 5. That's going to be 2 plus 5. So 7 squared plus, be careful, we have another one of those minus and negative, so it's going to be plus negative 1 plus 4 is that going to be 3? So let's see what we have here. 7 squared, would that just be 49? Plus the 3 squared, 9. It's going to be square root of 58, right? And, well, can we simplify square root of 58? Well, 58's not a perfect square. There's no perfect. What numbers go into 58? I can think of 2 times 29, and that's about it. There's no perfect square that divides evenly into 58. And so this distance, we can't simplify. You'll just type in square root of 58. Now, let's find the midpoint on this problem. Okay, so we want to find the midpoint. To find the midpoint, you just average the 2x values and average the 2y values. Can y'all see this? Oh, I changed colors. I was doing the midpoint in green, but I'm doing it in blue now. Okay, so it's going to be average the two x's. So average -5 and +2. So -5 plus 2, all divided by 2. And then average the two y's, -4 plus -1 divided by 2. And let's see, -5 plus 2 is 3. 3 over 2, so negative, thanks. -3 over 2. -5 plus 2 is -3 all over 2. And what about this? -4 plus -1 is -5 all over 2. There. When you type in that midpoint, it's very tricky. You must type this as an ordered pair, which means if I typed in this, -3 over 2, comma, -5 over 2, it's going to give me an error. Why?
Because you need the parentheses.
You need the parentheses. If you don't put those parentheses around it, it's going to count it wrong. And this is one of those times when it's smart enough. It'll say, okay, the numbers you got are right, but this is supposed to be an ordered pair. An ordered pair has parentheses. So this is one of those times when if you punch in the right numbers without the parentheses, it's smart enough to detect that and say, hey, put parentheses around it. So what I'm doing here is just sort of using the distance midpoint formula. But right now I want to go ahead and justify what the heck is that distance formula doing. The midpoint formula, it's just averaging. That's how you would figure out the number that lies between 82 and 100. Just average. That's what an average does. If you make a 0 on a test and 100 on a test and average those two grades, that's a 50. All that's doing is calculating what's right in the middle. So what the heck is the distance formula doing? That's what I'm going to try to answer right now. And I'm going to do it with,
I have a question.
Okay.
I got a little lost in that center part. 7 squared plus 3 squared equals 49 plus 9. How did you come up with that 9 on the end?
Oh, 3 squared, 3 times 3.
Oh, that's 9. Okay, I see.
And the 7 squared, 7 times 7, 49. The 3 squared, 9.
Okay.
And then you add the 49 plus 9.
I see.
Okay?
Thank you, sir.
Okay. Before I justify what the distance formula is doing, maybe I better review something from geometry. Okay? What I'm saying is the rest of what I'm going to be saying about this problem is justifying why the distance formula works. If you don't care, then this is one of those things you don't need to listen to. Somewhere along your life, you had some geometry, and a teacher would have told you about the Pythagorean Theorem. Theorem, if I can spell it right. Pythagorean Theorem, that has to do with the right triangle. If you have a triangle that has a 90-degree angle in it, the two short sides are called legs, and they're usually denoted with the letters A and B. Do you remember the name for the long side? It starts with the H. Hypotenuse. And we're going to denote the hypotenuse with the letter C. The Pythagorean theorem is a squared plus b squared equals c squared. That's, believe it or not, this is what the distance formula is doing. It's going through using the Pythagorean theorem. It's going to calculate A, then it calculates B. That's the subtracting here, the x2 minus x1 and the y2 minus y1. That's calculating the horizontal side, and the vertical side. And I'm going to demonstrate that by actually plotting out these points. I have some graph paper here, and I'm going to plot each of these points. Left 5, 1, 2, 3, 4, 5. I'm plotting the point -5, -4. That means move, starting at 0, move left 5 and down 4. Right here, this point is left 5, down 4. Yeah. Now let's plot the point right 2, down 1. There's 2, down 1. So I've plotted the 2 points, left 5, down 4, right 2, down 1. And let me go ahead and connect those dots. So connecting these dots. What we want to do is find the distance between these 2 points. Well, how the heck do we do that? Well, can y'all picture a right triangle? Could y'all draw a triangle here that looks like the one I drew right there?
Yeah, right there.
Yeah, just drop this. And let's go ahead and have a red side. So there's our right triangle. Let's start. Do y'all agree that the distance, this length here, would be that that hypotenuse C? So let's start counting. And if you don't have the graph paper, it's sort of hard to count it and see. But with my graph paper, let's see. How many units is it from here to here? 1, 2, 3, 4, 5. And then plus 2 more. 7 units. Up here, when we were going 2 minus -5, the 2 plus 5, that's what we're doing. We're adding 2 plus 5, that's getting us this length right here. Now, what about this vertical length going from here to here? 1, 2, 3. It looks like it's 3. Up here, the y2 minus y1. -1 plus 4, that's giving you that vertical length right there. So the x2 minus x1 gives you the horizontal. The y2 minus y1 gives you that vertical length. Now we're ready to say, okay, a squared plus b squared equals c squared. Notice we're getting those same numbers that we were getting up here. Oh wait, let me lift this up. I'm sorry. Okay, so notice we're getting the a squared plus b squared. That's the 7 squared plus 3 squared. So go ahead. 7 squared is 49. 3 squared is that 9 again. The 49 plus 9, that's 58. But we have 58 equals c squared. But we're not interested in c squared. We need to know c. What am I going to do to get c here? Square root. You take the square root. When we were solving quadratic equations, we'd go plus minus square root. But here, if we were talking about a distance, it doesn't make sense to talk about a negative distance. So what is this distance formula doing? When you see this x2 minus x1 and all of that. Well, the subtracting of the x's is getting you this horizontal length. The subtracting of the y's is getting you the vertical length. Why are we squaring them? Because we're saying a squared plus b squared. Why do we take the square root? Right here. If you know c squared, to get c, you have to take the square root. So if
then
someone...
c turns into the square root? Is that what you're saying, that the c becomes the square root?
No. We've solved things, think back. C squared equals, I'm just changing numbers, 16. This was called the square root property. To get c by itself, we'd say, okay, take the positive and negative square root. This was on assignment 2.
Yes.
Theoretically, what you're doing is putting a square root symbol on each side. And what happens to a square and a square root?
They cancel.
Yes. Okay? So what am I doing here? I'm taking the square root of each side. The square root and the square cancel out. I wasn't going to show that just because it makes it messier. There. And now we have the value for c. Okay.
That makes sense.
So that's what the Pythagorean theorem's doing. If someone asks, what's the Pythagorean theorem doing? It's, no, not what's the Pythagorean theorem. What's the distance formula doing? You can say, okay, it's using the Pythagorean theorem. Just saying that is enough. Okay? Any questions on that? I'm through explaining why. Let's do another one of these. Let's see. Maybe we should do one with cleaner numbers. By that I mean, maybe it wouldn't be a bad idea to do this one right here. Number 1. I don't want you to think that these are all going to always have negative numbers in them. Okay? So this is problem number 1. It says, find the distance between these 2 points. So the 2 points are 4, 12, that's my x1, y1, and 9, 17, there's my x2, y2. If you want to label them, first x, first y, second x, second y. I'm now going to rewrite this distance formula with the purple ink. So we're going second x minus first x. So 9 minus 4. And second y minus first y. You'll see why. Another reason why I didn't want to do this is the first example. Because I wanted to do one where we get different numbers. But here I think the horizontal leg and the vertical leg are going to be the same length, aren't they? The 9 minus 4, that's 5. So we have 5 squared plus, is it another 5 squared? The 17 minus 12. And let's see, how can I simplify that? Well, that would be 25 plus 25.
5. Wouldn't that be, I don't know.
Wait, you got to add them first to get 50. And now try to simplify.
5.
Okay, we can think of this 50 as 25 times what?
2.
2. So it's going to be 5 square root of 2, isn't it? Square root of 25 is 5. Square root of 2. So 5 square root of 2 is what I'll type in for that distance. What's the distance? 5 square root of 2. Are y'all caught up with me? Any questions? tough one. Now let's.
This one was easy.
Oh, okay. Yeah, this one worked out nicely, but showing the graph and stuff, the fact that the horizontal and vertical were both the number 5, I think it works better illustrating why if these are different numbers. If they would both been 5, then, well, which one of these is it? Which one's calculating the horizontal and which one's calculating the vertical? That was the major reason I didn't do that one first. Now, what about midpoint? Well, to calculate the midpoint, let me quit using this blue. It probably doesn't show. Calculate the midpoint. You average the 2 x's and then average the 2 y's. So you just add them up and divide by 2. Make sure you're going average the x's. A common mistake, people will just add x1 and y1. No. Add the x's, 4 plus 9, divide by 2. Add the y's, 12 plus 17, divide by 2. This is what's that first one going to be? 13 over 2 and 29 over 2. So what you're saying there is the number that lies right between 4 and 9 is 6.5. The number that lies right between 12 and 17 is 14.5. Okay?
So what would be the full answer? 13 over 2, comma.
Parentheses, 13 over 2, comma, 29 over 2. And when you're doing that, if you forget the parentheses, it tells you. Okay? And you have 3 chances, so then go in and put the parentheses around there. Okay? Huh? Usually they don't like decimals. My math, they're trying, right now they're working on it, I've noticed, where there's some of the times when it'll say use a fraction, but if you punch it in as a decimal, there are a few times it'll take it. Okay? But as a general rule, they don't like the decimals. Now let's do number 3. Okay? This graph depicts the growth and costs using a line segment. Use the midpoint formula. So even if you're not sure what understand the problem, it tells you use the midpoint formula. And that's going to help you approximate the costs during the year 1987. Well, in order to use the midpoint formula, you've got to have those 2 ordered pairs. So you're going to have to look at the graph and write out those ordered pairs. See, the first one, this point looks like it's a little off the line segment. It's supposed to be there at 1983. Our graph looks like, is that
3.9? Or
you write 1983, that's the x value, comma, the y value it's telling you, 5,033. You couldn't just look at that and say, well, that's obviously 5,033. And what about the second ordered pair?
1991.
1991, comma, 10,049. So, x1, y1, first x, first y, second x, second y, and we're just going to use that midpoint formula. As it says, use the midpoint formula. When we do this, it should get us an approximation for the year 1997, so just bear with it. Add up the 2 x's and divide by 2. Then add the 2 y's and divide by 2. The 2 x's are 1983 and 1991. The 2 y values are that 5,033 and 10,049. And let's see. Calculators create a glare when, oh, I guess it doesn't look that bad there. Okay, so 1983 plus 1991. Let me try it again. 1983 plus 1991. 3,974 divided by 2. Does anyone want to guess what it's going to give us?
1987.
Yeah, it better be 1987. So for the year 1987, what's this cost going to be? Well, add 5,030. Oops. What am I doing? 5,033 plus 10,049. Then divide that. That's 15,082. Divide it by 2. 7541. So what that's saying is that for the year 1987, the cost for that college was approximately, what number are we going to type in here? 7541. Okay? What it's doing is right there, looking right at that midpoint. Right between 1983 and 1991 is 1987. If you look up here and scan over, dot might not be exactly right. 7,541. Okay. Any questions there? Now, at this point, we leave the distance midpoint stuff behind, and we're going to start using some of the graphing tools. So I'm going to stop with this document camera, and I've already made a video with the graphing tools for y'all, but I'm about to show it up there right now. So let me cut this off.